Hey everyone, welcome. I am absolutely thrilled you're joining us for this explainer today because we are unpacking what I genuinely believe is a massive, fundamental paradigm shift in enterprise AI architecture. Look, if you've been following AI at all lately, you know we've been stuck in a bit of a rut when it comes to actual reliability. So today, we're looking at the architectural threshold that pulls us out of the conversational chaos of traditional chatbots and plants us firmly into the realm of deterministic, governed AI infrastructure. Let's get right to it.
Okay, let's dive into this. It is literally the multi-million-dollar question in the tech industry right now. Why do most AI systems hallucinate workflows? I mean, we've all seen it, right? You ask an AI to perform a specific enterprise task, and instead of just following the rules, it decides to improvise. It invents new buttons to click, it totally makes up internal terminology, and honestly, it acts like it owns the place. And it's not just annoying. In an enterprise setting, this is a severe systemic problem. The unpredictable behavior of these systems makes them incredibly difficult to trust with anything that actually matters.
So the root of this problem is what we call the AI layer collapse. Think about it. When you mash up an AI's ability to think and reason directly with its ability to execute commands, things get chaotic fast. Most AI systems out there right now collapse these two layers into one big probabilistic mess. And the result? You get hallucinated workflows where the AI just invents steps that don't even exist. You get route drift where the internal navigation paths silently change on you. The UI vocabulary becomes completely unstable because, well, the model is basically just improvising the wording every single time it runs. And worst of all, this layer collapse leads to total governance inconsistency, accidental authority escalation, and massive prompt injection instability. It's dangerous, and frankly, it's exactly what happens when you treat a critical enterprise tool like a free-form creative writing exercise. To understand exactly how we solve this, here is our roadmap for today. 1. The AI layer collapse. 2. The architectural threshold. 3. Left brain versus right brain. 4. The enforcement mechanisms. And finally, number 5, the hybrid AI future.
Section 1. The architectural threshold, moving beyond prompt conditioning.
To fix the total chaos we were just talking about, the developers over at Enkai realized they had to build a fundamentally different class of system. So they created a deterministic semantic presentation substrate. Okay, I know, that is an incredibly dense, highly technical mouthful of jargon, but let's break it down together. Think of it as, well, actually, think of it like a heavy-duty, governed operational wall. It's a solid boundary that sits right between the AI's free-form probabilistic language generation and the actual execution of your real-world operational systems. It is the protective shield that literally stops the AI's creative brainstorming from accidentally pressing buttons in your database.
Now, what's really interesting about this slide is the stark contrast between the old way of doing things and the new. Before this architecture, we had probabilistic, improvised wording. The model was basically just guessing at what operational surfaces should look like. Canonical route names were drifting all over the place, and secure governance vocabulary was constantly leaking out into casual chat. But now, with this new layer firmly in place, operational surfaces are extracted straight from canonical sources. The exact wording is perfectly preserved, the presentation order is totally stable, and the integrity of the whole thing is continuously validated by regressions. We have literally moved from a system that guesses to a system that knows.
Section 2. Left brain versus right brain. The anatomy of governance.
Let's break down the core scientific change here. On the left side, we have generative reasoning. Think of this as the left brain. It remains entirely probabilistic. It's flexible, it's highly adaptive, and it's totally non-deterministic. This is the side of the AI that you absolutely want for brainstorming, interpreting context, and synthesizing complex information. But then on the right side, we have deterministic operational surfaces. This is the right brain presentation boundary. It is canonicalized, it's stable, reproducible, and incredibly machine-safe. This is the side you strictly use for menus, approvals, governance verbs, and routing identifiers.
So the absolutely crucial point here is this. You cannot have a reliable enterprise AI without strictly separating generative reasoning from deterministic operational surfaces. You have to let the AI be creative when it's reasoning, for sure, but you must completely lock it down when it comes time to actually interact with operational menus and make real decisions. That strict separation, it's the absolute bedrock of governed human-AI interaction.
Moving on to Section 3, the enforcement mechanisms, registries, and regressions.
Okay, so we understand the philosophy now. Separation of powers, essentially. Let's look at the first enforcement mechanism that actually makes that happen, the structured surface registry.
Functionally, you can think of this registry as the ultimate traffic cop. It identifies all the operational surfaces the AI might ever need to use, maps those surfaces directly back to your canonical sources, and figures out exactly what the deterministic requirements are. And really importantly, it binds regression enforcement right to them. Scientifically speaking, this registry is a semantic governance layer. It creates these strict, uncrossable boundaries inside a probabilistic system to prevent the AI's meaning and vocabulary from slowly drifting out of bounds over time.
And that brings us to the second mechanism. Regressions are integrity monitors. And this is vital, because without regressions, AI systems are notorious for silently drifting. Over time, the way they respond to your prompts changes, their vocabulary mutates, and their authority semantics degrade without anyone even noticing, usually until it's way too late.
So what do these regressions actually do on a day-to-day basis? Well, think of them as governance verification probes that are just running constantly in the background. They are always checking the system to verify that canonical surfaces still exist exactly as they were defined. They verify that required governance verbs, words like approve, deny, or escalate, remain completely intact and haven't suddenly been swapped out for some casual synonym by a creative AI. They ensure that the operational semantics remain rock solid and stable. No surprises.
And this brilliantly illustrates how AI engineering is finally catching up to traditional software engineering. In traditional engineering, we rely really heavily on unit tests, protocol conformance tests, and API contract validations to ensure a system doesn't just spontaneously break when we push an update. Well, and Kai has essentially introduced the exact equivalent of this for AI semantic checksums. They're applying those same rigorous battle-tested stability checks, but they're applying them directly to AI human governance services. It is a massive leap forward in maturity for this tech.
Section 4. The Hybrid AI Future, Beyond the Chatbot.
This leads us to an ultimate architectural truth, and it's a quote I absolutely love. You are separating conversation from protocol. We are finally done playing this endless, exhausting game of trying to control the model with increasingly complex prompt engineering. Instead, we're doing something smarter. We are constraining the operational semantics. We are separating cognition from authority. We are separating the AI's ability to chat with you from its ability to execute critical protocols.
So what is an accurate scientific description of this system today? It's a hybrid, deterministic, probabilistic cognitive governance architecture. The probabilistic side handles all the fluid interpretation and complex reasoning. The deterministic registries step in to strictly govern the operational semantics. The regression systems act as the guardrails, preserving that semantic integrity. And crucially, because of this really clear boundary separating cognition from execution, humans remain the final, secure decision authorities. Make no mistake, this is materially, structurally way more advanced than just wrapping a user interface around an LLM. To really cement this new mental model, think about the difference this way. A chatbot gives you a conversational illusion. It's a prompt-engineered wrapper that feels really smart, but structurally, it's hollow. But the architecture we've explored today, it belongs in a totally different category. It's much closer to avionics, medical review systems, or industrial control cognition. It offers governance-grade orchestration and deterministic routing. I mean, think about it. If you were flying on a plane, you wouldn't want the autopilot creatively guessing at what the controls do based on probabilistic reasoning, right? No way. You want deterministic execution. Enterprise AI requires that exact same level of rigor. Ultimately, that is the single most important takeaway from today's explainer. By embracing deterministic registries and regressions, you finally stop trying to wrangle totally unpredictable text generators. Instead, you are building robust, reliable, semantic infrastructure, instead of just a fragile conversational illusion.
I want to leave you with this final thought to ponder today. As AI inevitably takes on more and more critical, high-stakes roles in the enterprise, I want you to look at your own systems. Are you just building conversational illusions that might hallucinate at any given moment, or are you building governed semantic infrastructure that you can actually trust? It's a question every single organization needs to answer. Thank you so much for joining me for this explainer. Keep learning, keep building, and I will see you next time.